Thanks for joining us on this Friday, December the 18th, 2015. This is going to be our last weekly space hangout for 3 weeks, so there'll be no space hangout next week. There's some kind of holiday for somebody, and then there's another sort of holiday the week after that, so we're going to take the time off, and then we will come back on the next week and do more shows. So please don't email me if you don't get your weekly space hangout next week. It didn't happen. But this one is definitely happening. So joining us this week, we've got Sandy Springman.
Hi.
Who is currently attending the AGU, right?
I am not attending the AGU.
No,
I'm attending to my mother who had her right knee replaced.
Oh, then you're mentally attending to the AGU. Pamela's actually at the AGU.
I saw her last night. We had a CosmoQuest dinner.
So you're in the same city as the AGU, but you're not actually attending it?
I'm an hour north of San Francisco. I'm in Ewok country.
Right, as mentioned before. Dave Dickinson. Hey, David.
Hey, saw Star Wars this morning.
Yeah, well, you should tell people your story here about why you chose your hotel room.
Oh, the hotel I'm staying in is right across from the theater, as a matter of fact. We're kind of traveling right now, so we picked this deliberately so we can go over and get a good seat this morning.
Perfect.
And I won't give any spoilers, but they still don't address the fact that a parsec is a measure of distance, not time.
Oh, but do they reinforce it? I can't even watch.
There is actually an explanation for that, Dave.
Yeah,
I've argued with people.
Oh, that explanation is bananas and just post hoc rationalization.
It makes complete sense to me, Fraser, and I am a licensed quantum mechanic.
It makes sense to me too.
Yeah.
I know black holes.
All right. And joining us as well, we've got Kimberly Cartier. Hey, Kimberly.
Hey, Fraser. I also saw Star Wars.
Why don't you give us the short version on why a parsec can be a unit of time and not distance?
Well, it's not so much the fact that it can be a unit of time, but the Kessel Run itself is it's a travel route between two different locations that passes by a planet called Kessel. Right next door to Kessel is a big cluster of black holes that you're not really supposed to fly anywhere nearby because black holes are really dangerous and stuff. So normally the Kessel Run takes something like 20 parsecs, just the physical distance you're traveling, but Han Solo, because he's such a clever flyer, flew very, very close to the black holes and shaved off many, many parsecs from his travel, which is why it's famous.
And you believe that's what George Lucas had in mind when he wrote that in the script?
No, I think that's totally after the fact.
No, I am totally with Kimberly. The first time I saw this, and before I discovered Star Wars fora or theories about this, it was like, oh, right, yeah, there must be something hazardous, a debris field or black holes, and he did something very risky to shave off a lot of time, and therefore he did it in a shorter distance than people usually do, and it made complete sense to me. But
I think of it like a shortcut between LA and New York.
Sure. In a post hoc rationalization kind of way, it makes perfect sense.
Yeah,
it works very well with all the novels.
Of astronomy kind of way when I write science fiction scripts, there's a problem. But anyway, you know what? I am not going to make any fun of George Lucas today on his special day. Joining us again for the second time, for the first time, we've got Miguel Drake-McLaughlin, the director of Skynet. Hey, Miguel.
Hello. Great to be back.
Yeah, that's great. So this is the first time we've had a guest here twice, and in this case that was because we're having all kinds of technical problems about 3-4 weeks ago when you tried to join us, and so we thought we would we'd let you pull a mulligan and come back, and we'll take another crack, and we'll do another get a bit of an update from you. So let's take a little while and talk to you about. Well, first, have you seen Star Wars yet?
No, my Star Wars status is not yet seen. My brother is joining me in New York today, and I should get a chance to see it with him soon.
All right, and so I guess when last we saw, a couple of weeks ago, you had literally just posted your You had just gone live with your documentary. So how's everything going?
Things are going great. We're getting a lot of interesting feedback from scientists and a little bit of press. I think we were on the front page of Gizmodo on our launch day, and we got a lot of great comments from that. And since then, we also were able to do a Ask Me Anything with some of the scientists in our film, and it's great to see people's response. We made the film because we want audiences to think about this possibility of building a huge elevator to outer space, and it's been great to see people questioning and wondering if it's possible and how it might work.
So since you did your documentary, has the space elevator been built yet?
No, we're
Uh-oh.
Speaking of technical problems.
maybe take decades.
Okay, so and so for anyone who I guess maybe is unclear on the concept, let's do another kind of quick sort of explanation of sort of what you guys decided to focus your documentary on.
So we decided to work on Skyline because we were interested in the idea of in some senses existed since before language. You see reference to tall towers going back through history, but has been kicked around by the scientific community in the 20th century and more recently as something that might be possible by using the centrifugal force of the Earth's rotation to keep the elevator tight, and might be a way to go to space without consuming fuel, without burning rocket fuel. And it's an idea that is both fantastical and I think potentially very practical. And so we wanted more people to kind of think about it and to address the challenges that need.
So you're sort of cutting out a little bit. So as sort of based on going into making this documentary, you were, I'm sure, a sort of a fan of the idea, but in actually, I guess, getting a chance to talk to the people who've really dedicated a big chunk of their lives to pushing this idea to the next stage, what did you learn?
Is that practical progress. No one is out building an elevator right now, but it's also something that could so revolutionize humans' access to space that we found people are being made in material science, which is the main problem, and we see news about new progress in that area, constantly as day.
And so what is the biggest technical hurdles now to overcome this?
The elevator would be quite large. It might and because it's so large, it would be very heavy. And making a material that's strong enough to hold its own weight is the central issue. And they're in our film who've made progress working on carbon nanotubes, which is considered a hopeful material for that, and in theory is possible, but that is the central problem, is creating a strong enough material.
And so, I mean, is it physically even possible to, like from a pure math, physics, chemistry standpoint, can a strong enough material be manufactured? Not even talking practically, like is it even just theoretically possible?
Yes. At the time that Jerome Pearson first wrote about the space elevator, he said you would need unobtainium to build it because it was not possible. But there have been breakthroughs in theory with regard to a material called carbon nanotubes, which is a potentially very, very strong material under tensile pressure. And there are other materials that are being developed right now that are similar kind of single atom, like molecular, as graphene, which is another kind of thing that hold up really well under tensile strength. And so there's been a lot of material science research, and there are other candidate materials as well.
Very cool. All right, so we're having a lot of sort of communication problems. You're sort of cutting in and cutting out about half of the time. So I think, and I'm not sure sort of what is the internet is doing to get from where you are to Google Central, but it looks like it's not being kind to you. But let's make sure that everyone gets a chance to find out more about about the documentary, where they can pick it up now, and just make sure they get a chance to go and check it out. So have there been any changes? Where, if I wanted to go and watch this, where can I go to watch it?
If you can visit our website, spaceelevator.net, there's a link to VHX on there, and Skyline is available on iTunes, Amazon, Vudu, and a few other platforms as well. And Google Play is also a major platform for it.
All right. Well, Miguel, thank you so much for joining us again, sort of about the communication problem, and thanks for making this, for going into what is like a total space nerd fantasy for all of us, and unlike Star Wars, is bordering on the realms of reality, and it really is our ticket to space. So thanks a lot for investigating it. One last question. Now that you've done this, do you think you'll do more about space, or do you think you're going to head off in other directions?
I absolutely have more material in the works about science and space and technology. They're not quite ready for announcement yet, but they will be in the coming months.
Awesome. All right. Well, thanks, Miguel. Thanks for joining us at the Weekly Space Hangout again, and have a good holiday.
That's interesting.
Great. Thank you so much.
See you later.
Bye.
All right. Let's move on to some of our stories. Let's see. Normally, last week I went alphabetical. No, I went reverse alphabetical. So I'm going to start from the middle. And David, you are working on a monstrosity again for Universe Today.
Yes.
Can you give us the lowdown on what's about to be unleashed?
This is a blog post that takes me 6 months to write every year, and I've been doing this since on one platform or another since 2009. It's the third year I've been doing it for Universe Today. I'm doing all the astronomical events. It's not quite a top 10 listicle, and it's not a full almanac. It's like 101 events. I drill it down with occultations and close conjunctions that are closer than a degree with naked eye planets, and lunar and solar eclipses, and what bright comets we think are going to be bright, which is a little more of a black art to divine. But I'm pretty close to getting this done. I need a few bits of information from a few people. We're going to have it where we have an iCalendar link that's going to put this all right into your calendar. We did this last year too, and that's going to be pretty cool. And there's a few more graphics I want to include that I'm waiting to get some people to build them for me. But next year, there's going to be, one of the cooler things is going to be a transit of Mercury. And that's the only one that's going to happen this decade. You might remember the transit of Venus in 2012. That's a little more rarer than a transit of Mercury passing in front of the sun. The last transit of Mercury was in 2006, and I did a public event at the Flandreau in Arizona when I was working there. I nearly died of heat stroke standing out there with the telescope pointed at the sun in Arizona for a couple hours, but it's kind of cool. The Mercury one is going to be visible through the Atlantic region on May 9th, and that's the only one this decade. So it's going to be visible for North America, Europe. That's going to be kind of cool. There's the last total solar eclipse that's occurring for Southeast Asia on March 9th, and that's going to be the last total solar eclipse until the big one in August 21st that passes over. It's going to be an annular eclipse next year. Incidentally, we got so used to having total lunar eclipses with the last tetrad, there are no good lunar eclipses now for the next few years. There are two penumbral eclipses, but if you've ever seen a penumbral lunar eclipse, it's almost a non-eclipse. the moon just passes through that very faint outer shadow. What I have done during a penumbral eclipse that's kind of cool, photograph the moon before and after, and photographically you can see the difference, but to the naked eye it really, the moon will look like it's shaded, tinted, maybe a little brownish when it's in the shadow. So the solar eclipses are the big eclipses next year. And I'd say next to the transit of Mercury, the other big thing is the opposition of Mars. That's happening May 22nd next year. We're getting oppositions they're not all Martian oppositions are the same because Mars has a very elliptical orbit. And we're coming off a bad series of oppositions for the last, every 26 months or so you get an opposition of Mars. We're coming toward a better cycle right now. This is the best one for the last decade. And in 2018, we have one that's going to be nearly as close as a historic 2003 opposition. So I expect that's going to be a big deal as well. And this one's going to be pretty good too. So it's going to be a good time to get out and observe Mars. And actually, it's really the only time right in the month or so leading up to opposition you can see details with a small telescope. And you can see the rotation. Mars's rotation is only 30 minutes out of sync with ours. So if you watch it at the same time every night, you see nearly the same longitude. It turns just a little bit every night. So you can actually see that difference if you get a good shot at observing it every night. And another thing that's interesting I just found out is that we're going to have, it's a supermoon, but it's going to be an exceptionally close one next year. We're having a perigee moon on November 14th, and this just by a smidgen is going to be the closest one for the next 30-year span. Now, the moon reaches perigee every synodic period, every 29.5 days. It gets nearly as close. This one's probably going to have that cultural break. You know, people love the supermoon. I don't know why, but it's just that thing on the internet that the moon is pretty close every full moon and every perigee. But I suspect this is going to be a big deal to the internet anyway. It's going to be a big deal. And, you're going to have the usual stuff, the Perseid meteors, quadratids, geminids, that's all going to be in there. I composed all the asteroid occultations of stars brighter than 8th magnitude. There's an interesting occultation I just found out about in 2019 of Sirius over the southwestern United States by an asteroid. So that is going to be, because Sirius is the brightest star in the sky. So
yeah, so you're actually going to be able to see Sirius.
Yeah, and that's one of those occultations like the one we had with Regulus a few years ago. There
asteroid?
Is one. Yeah.
Which asteroid?
Which asteroid? Oh, I'd have to look it up. It's not a well-known one. It's
That's
not like
really exciting. Do you know when is this exactly?
2019.
Okay. Hopefully I'll be graduated by then.
Yeah.
I need some occultations for my asteroid, David.
Yeah, you have an asteroid. That's kind of cool.
What you need to do is not only get more observations of your asteroid to improve its ephemeris, but also to get more observations of stars it might go over just to improve their positions.
I've never seen it come up in all these lists of occultations. I've never seen it. I think it's F. Cain is the asteroid.
Fraser Cain, yeah. It's got a number, but yeah. Well, that sounds great. So anything else? Is that
I usually like to put it out on that week, but after Christmas, because everybody's brains start turning toward 2016 the day or two after Christmas and stuff. So probably December 28th, I'm going to push that out there. But no, these are fun to do, and it kind of gives me a home base for everything else I write for the next year. Barring, of course, those things like bright comets or Chelyabinsk meteors or things that we just can't predict that are going to be cool. So
like the comet that the universe owes us.
Yeah, where we get one. We usually get a bright comet once per generation, once per 20 years, and we haven't. Hale-Bopp. We had a few other ones but they were mostly southern hemisphere comet. There was a comet Linear, I think, in 2006 that was kind of bright, was naked eye, but not a brilliant, spanning half the sky. That was Hale-Bopp and Hyakutake back in the 90s. We got spoiled back then.
Yeah, we thought those good times would last forever.
Yeah, because those came by they were almost in the sky at the same time.
Yeah.
And Hyakutake was actually kind of interesting because it actually came moderately close to the Earth for a comet. So it came up. We knew Hale-Bopp was coming before that, and then Hyakutake just came out of nowhere. So that was kind of interesting that it just kind of crept up on us. And the internet was a baby then. There was no Twitter. There was no Facebook. So.
Good. And so we should expect this to drop sometime after Christmas.
Yes, probably a day or two after.
actually, and then we will promote the hell out of it. So just,
People
everyone should just stay tuned because they'll hear a lot about this thing, and we'll try to make it as handy and useful as we can to everybody. So as always, it's an absolute treat to see this thing when you write it, David, and I am looking forward to it. I'm especially looking forward to your 2017 edition, but the 2016 edition will be good.
Oh, yeah.
And of course, there's like in the 2020 edition, I think it is, there's going to be a Saturn and Jupiter are going to be like within the same telescope diameter.
Yeah, I wonder if we're still going to be blogging by then, or we'll just be beaming it from our brains. Or
from our brains. In 4 years, I think we'll still be blogging.
We'll still be blogging.
Yeah. Awesome. Okay. All right, Sandy, what is going on with all those geophysicists?
Okay, so there's a lot of things going on. So if you're not familiar with the annual American Geophysical Union meeting, about 20,000 geophysicists, and I use that term very lightly because on Monday night I was at a reception and I was talking with some people who study snow. So they resented the fact that I called them geologists, but they're doing Earth stuff, so they're geologists in my mind. They were not amused. Anyway, so there's 20,000 people, a lot of people who do Earth stuff, whether it's geology on Earth or geomorphological processes, water monitoring, oceans, atmosphere, snow, you name it. And there are a lot of people who go to AGU from the planetary science community, so especially MAVEN, which is the mission at Mars. It's studying Mars's atmosphere and has figured out that Mars has lost a lot of atmosphere. And there are a lot of Pluto people at AGU this week. So it's a really exciting time for planetary. The planetary stuff is sort of end-loaded this week, so today there should be some exciting stuff. And there's been some really cool images of Pluto that have been released. So get off your smartphone and get onto the largest monitor you can find, unless that's your smartphone, and go look at these incredible scans of Pluto. And so these are, the details are, hundreds of meters across at the smallest, and there's even these things that look suspiciously like they could be ice volcanoes. So there's this Right Mons, which again is an informal name. If you're not familiar with what's going on with Pluto, there's a lot of names that the science team has been using to refer to features on Pluto, but they haven't been approved by the IAU yet. So we have to say they're informal names, and every time someone says an informal name, you should drink. So Right Mons, they think, might be an ice volcano. And so ice volcanoes are actually really hard to form because of how just the properties of ice. What happens to ice is it cools and heats and melts. It's really easy to form volcanoes out of rocks that we have here on Earth. When you melt them, it changes their buoyancy, it changes their density. Ditto with ice, but it sort of goes the other way around. When ice melts, it actually increases in density. So that's kind of weird. So it's hard to form ice volcanoes unless you have antifreeze in them, unless there's a lot of methane, and there's you have to have really just perfect conditions for cryovolcanism, as we call it. So there is some chance that this Right Mons, which is about 4 kilometers tall, actually might be some sort of ice volcano. And if you think about the shape of Pluto, which is really spherical, it means the inside of Pluto had to be, it had to stay molten for a while, and it had to be liquid for longer than we would have thought in order to keep that really round shape. So maybe the surface of Pluto is really young. Maybe this ice volcanism is actually a thing, and it happened recently, and it's actually kind of exciting. We've not actually seen ice volcanism anywhere in the solar system. There's suspicion of it on Titan, Saturn's moon. There's suspicion of it on Triton for Neptune, but we really just don't know.
That is really cool. So if it's confirmed, then this would be the first example of actual active cryovolcanism.
I don't think it's necessarily active, but I guess recently.
Okay, past
ice volcanism. If we can actually confirm it, that would be great.
Like Olympus Mons is potentially past shield volcano.
Yeah, it's an actual volcano. It's a silicate volcano, and so the deal with Mars is that Mars is small and that it lost a lot of its heat very early on, and so it doesn't have a molten core, and it doesn't have plate tectonics like the Earth does. And so it doesn't have plate tectonics, which means that if you've got like a hot spot in the mantle that's going to push magma up toward the surface and erupt into lava, it's just going to keep erupting in the same place. Whereas on Earth, where we have hotspot volcanism in Hawaii, you see the Hawaiian island chain sort of grow and then shrink as they move away from the hotspot. and that's due to plate tectonics, whereas on Mars there aren't plate tectonics moving material away from hotspots. So we do see volcanism on Mars, evidence on Mars. We see evidence of volcanism on Venus. There's even some insinuation by the Russians that there's active volcanism on Venus, which is pretty wild. And we see it on Io, Jupiter's moon. So
sure.
and we've seen it probably on Mercury, and I think there's maybe some stuff on the moon, but we've definitely seen lava plains, but we haven't seen confirmed evidence for cryovolcanism yet. And the other thing I want to call attention to in this new image, just before we get anywhere, is Alex Parker has this great tweet about it, and he just says, so much contrast, so many kinds of landscapes. And there are wrinkles, there are ridges, there are mountains, there are pits and craters. Pluto is really a very diverse surface. So.
Cool. Okay, what else?
So that's been going on. The other thing that you should go check out is go to the Planetary Society and go to Emily Lakdawala's blog at planetary.org and check out these Rosetta Science images of Comet 67P Churyumov-Gerasimenko that Emily Lakdawala has been reprocessing. And holy cow, you get to see this comet like never before. And if you have 3D glasses, you should bust out your 3D glasses. There's an animation of a spinning comet. There's a photo, Emily posted a selfie of her with her really cool 3D glasses working on this. And you see a really lot of variation in terrain on Comet Churyumov-Gerasimenko. There's soft, smooth-looking terrain. There's more jagged, older terrain. So who knows what's going on there. But definitely do bust out the 3D glasses for Hat Meth Regio in 3D. There was Enceladus sessions yesterday. There's a lot of atmosphere stuff that happens at AGU, for planetary people. So it's a cool meeting. I've actually never attended, but since I'm from the area, I always try to crash the MIT alum meetup on Monday night.
Well, the trick is you just need to get to your journalist credentials, and then you can go for free.
Yeah, exactly. But then I actually have to write stuff when I have a day job.
No one checks. No, all of the journalists that we supply to the various meetings all work very hard, and we really appreciate access to your events. Please don't cut us off. Okay. All of the events that all of our reporters get into, we work very hard to bring the best news from everything that's going on. Please don't cut us off. Okay. Cool. Anything else? Are you? Let's give Kimberly a chance, and then maybe if you have anything else that you've dug up at the AGU meeting, we'll come back around. All right, Kimberly.
Hi.
Let's talk about naming worlds first, and then we'll move on to your other story as well.
Sure. Yeah, so one of the most common questions I get asked whenever I speak in public about exoplanets is why don't they have clever names? Most of them are still named based on the stellar catalog that their star belongs to, HD followed by a series of 6 or 7 numbers that no one can really remember, and they shouldn't really be expected to. And the biggest question is, why don't we just give them names? Well, the answer, I think Sandy alluded to, was the fact that to make a name of an astronomical object official, it has to be approved by the International Astronomical Union. And they generally take a very long time to get around to naming things, usually because they want them to be really confirmed and well studied, and they want to make sure that they understand as much about it as possible before they name something officially. Well, exoplanets have been around now for 20-some years, and they thought it was high time to actually give exoplanets names. I fully agree with that. And so this past summer at the IAU meeting in Hawaii, they opened up a public Name Exoworlds contest or vote, whatever you want to call it, where they solicited names from the public, not just from astronomers, for the first 31 exoplanets that were discovered, the 31 most famous exoplanets that we've found so far, including the first pulsar exoplanets and 51 Pegasi and the 55 Cancri system, systems that we like to talk about a lot, we like to study a lot. And just recently, earlier this week, they released the official names for these exoplanets. The names were submitted from 45 countries from around the world. The names that were selected come from North America, they come from the Pacific, from Asia, from Europe, from everywhere. And some of them are actually, they're quite interesting names, I have to say. The 55 Cancri system, whose names were chosen from a list submitted by the Netherlands, actually goes, all the stars and the 5 planets in the system are named after famous astronomers. So that's a sort of an obvious one. There's Copernicus and Galileo and Brahe, and they all correspond to different planets. My personal favorite is the Mu Aries system, whose names were submitted by a group from Spain that actually go from the novel Don Quixote, and so all of the star and the planets are named after characters and the author of the Don Quixote novel. So that's actually my favorite, I have to say. But it's nice that some of the most famous exoplanets, the ones that we talk about and that are a lot in the public eye, actually have official names, and we don't have to call them by their telephone numbers anymore.
And unlike the Name a Star services, where all you're really doing is putting a name into some directory at this company, and it's not officially recognized by the IAU, these names are officially recognized by astronomers.
Yes, these are officially these are now the official 100% official names approved by the International Astronomical Union. They have an executive committee working group on the public naming of planets and planetary satellites. All of the names were vetted and approved by them. So these are the official names now. So if you give public presentations, if you're writing articles, if you're giving scientific presentations, go back and change the names of all your planets.
They need to name them after Star Wars worlds.
No, there's a quite strict list of guidelines of what names can be chosen, yes. And one of the restrictions is that it cannot be a copyrighted name.
Okay.
So no Star Wars planets, no characters from copyrighted books or novels. I think Don Quixote's been around long enough that it's no longer under copyright.
We'll have to wait for Disney to give up the copyright in a few centuries.
I highly doubt that'll happen anytime soon.
Yeah.
But a lot of the names are chosen after like deities from Norse mythology or Asian mythology. So I can't pronounce all of them yet, but I'm going to try and get familiar with them. For those who are curious, 51 Pegasi, the star, is Helvetios, and 51 Pegasi b is Dimidium.
I love the pulsar ones. So they're
the pulsar ones are really fun.
Lich, Draugr, Poltergeist, and Phobator. So I guess those are all, I don't know, those are all monsters you'd fight in a D&D game, I think. But maybe there's
Phobator sounds cool.
Yeah. They sound like scary monsters that come out in the night. Very rough and tumble. Sci-fi.
But you know that, I mean, there's probably a couple of stars left that don't have names in the galaxy, or 400.
Just a few.
You know, or a few 100 million. So I think there'll be lots of room for everyone to get to name a star in the end.
Oh yeah, there are still plenty to go. This is just 31 out of nearly 2,000 exoplanets that have been confirmed. So this is just the first batch, but it's pretty exciting that the names were publicly solicited and publicly voted upon.
That's awesome.
This is what the world has chosen.
All right, let's move on to your other story, which is a hot Jupiter water mystery explained.
Yes.
Explain it.
Hot Jupiter water mysteries. So, hot Jupiter planets, which are Jupiter-sized planets that orbit extremely close to their stars, have started coming more to the forefront of astronomical research as we are preparing for the launch of the James Webb Space Telescope. Specifically because we're looking forward to James Webb because it will show us the atmospheres of exoplanets, small exoplanets. But right now we can look at the atmospheres of larger planets that are very close to their stars, just like hot Jupiters. So that's what we've been doing for the past few years and what we're going to continue to do. And when we've been looking at the transmission spectra of hot Jupiters, where we're looking at the starlight as it's passing through the planetary atmosphere and then comes to us, we noticed that while some hot Jupiters have a very strong water signature in their atmospheres, some of them don't. They have a very weak or completely absent water signature in their atmospheres, which puzzled us for a very long time because it would indicate that maybe some hot Jupiters form in a way that is different from the standard planetary formation model. Our general understanding of chemicals and molecules in the universe is that water is extremely common. It's very easy to make because it's small and it's made of two of the most common elements in the universe. So it should be very abundant. And the only way to make a hot Jupiter planet, which would have needed to form very early on in planetary formation to accumulate that much mass, was that the protoplanetary disk just didn't have water, which was a very strange idea because water is supposed to be everywhere. So luckily, a team of astronomers came up with a much more clever idea. It's not that the water in the hot Jupiters is missing, it's just that we're not looking in the right place to see it, and that what water is there is being obscured by clouds and hazes in the hot Jupiter atmosphere. So they sampled 10 hot Jupiter planets, which may seem like a small number, but there are actually very few planets we can do this for in high confidence. And they took very high detailed spectra using Hubble Space Telescope and using Spitzer Space Telescope in the visible, near infrared, and far infrared, so getting a very wide range of wavelengths to try and find water if it's there at all. And they found that for the planets where the water features are not obvious, the signatures for clouds and hazes are much more apparent. And that when you look in the places where the clouds and hazes don't have as much impact, you actually do see the water. So their conclusion is that all hot Jupiters have water, and the visibility of them is a continuous spectrum just dependent on how much clouds or hazes are actually in the hot Jupiter atmospheres. So, mystery solved, hopefully.
Fun. Whew.
Whew.
That was
It's keeping me up at night. It really was.
Yeah. Yeah.
Actually,
well,
it
and
was
now
because
these hot Jupiters have names, so.
So yeah, some of these hot Jupiters have names now. I joke that it was keeping me up at night, but it really was because my current research project is about spectra of hot Jupiter atmospheres looking at water features. That's actually very relevant to what I'm working on right now. So that was actually a very interesting discovery for me personally.
What do you do as a researcher when news like that comes in sort of at a really appropriate time? Do you rewrite a paper that you're working on to incorporate it? Do you collaborate with the authors?
It depends on the timing of the two studies. If you know of another group who is working on the same thing that you are and trying to get the same answers as you are, usually astronomers are friendly enough to reach out and say, hey, I'm working on the same thing. Do you want to combine our proposals together and make a much stronger statement with all the extra data? Usually it works out pretty well. Sometimes people prefer to keep their separate works.
Keeping an eye on the Nobel Prize number, right? Is it 3?
3, yeah. So if you're already in the middle of a study and something new comes out like this, you definitely want to incorporate the most recent results you can and frame your conclusions around that. You definitely don't want to be a year out of date in your conclusions.
All right, so David, there's a little bit going on with SpaceX right now, right?
Yeah, actually, I got a little bit of breaking information on Twitter on that as well. Somebody shot to me. SpaceX was planning on tomorrow night doing their launch of the Falcon 9 from the Cape. They're launching an Orbicom satellite, so they're not going to the ISS. And it was interesting. This is a very high-profile launch for two reasons, because one, they're returning to flight after the summer, and they had a mishap this summer with Dragon going to the ISS that exploded about a minute or so off the pad. Actually, I think that was like 22 seconds off the pad. And also, this is the first time they've got permission from the U.S. Air Force to land the Falcon 9 Stage 1 back at Cape Canaveral Air Force Station. They weren't going to, and they haven't successfully landed on the barge. They've gotten close, but this time they were going to try to bring it back and land it at the station, so that would be on the mainland, so that would be interesting. However, I just got a notification from @SandyGrains that follows me saying probably not going. She retweeted Elon Musk. Apparently they're doing the static fire test out there today. Usually within 48 hours or so they do a static fire test of the engine to check it out. And Elon Musk apparently tweeted within the hour, holding for issue resolution, and Sandy Grains is saying probably not going up this Saturday due to propellant cooling issues, static fire test not doing too well. So I suspect that means we're probably not going to, it's not official, but I suspect they're going to push back. This is kind of interesting. I would like to know why, as a non-rocket scientist, they're doing their very first landing at night. We were talking about before the show. I think you would probably want to try to do it in the daytime to do your very first one, but maybe, I don't know, there's something I don't know, nighttime versus daytime isn't an issue, or maybe it's the only window they have to, I notice it's a 3-hour window to launch the satellite, so it's a quite wide window. When they go to the ISS, usually it's a lot narrower, and sometimes the window to hit the orbit they need is instantaneous, so it's interesting they're going to try to do their first. I would imagine if they slide back, unless there's a range issue, they're probably going to go back to Sunday night. If you remember the Cygnus launch that I went over for recently this month, that slid back about 4 or 5 times before they finally went. The weather hasn't been really cooperative here in Florida either, so apparently they're not going tomorrow night, but I would stay tuned. They'll have it live on NASA TV when they go up too, so it'll be interesting to see the footage we get. If nothing else, it's a great show to watch them try to land on the barge. It always makes for great videos, so we'll see if they try to land back on the mainland. We should get a lot of good footage out of that. We might be able to actually watch it as it's happening live. That would be kind of cool, because usually before on the barge we see the video like, you know, within a few hours or the day after or something like that. To watch it live might be kind of neat.
Would you be able to watch, how far away are you right now from where it's going to take off?
Oh, I'm back in Tampa, but here at night we're about 100 miles to the southwest. At night you'll see it. If the skies are clear all the way across the Florida Peninsula, you'll see a night launch. When the shuttle used to go up, it was very brilliant. And the satellites aren't, not so much, depends on the orbital geometry they're trying to hit too. If they're going to the ISS, they're going up to the northeast because they got to chase after the station in its 52-degree inclination orbit. So you get a good profile right up the Atlantic coast, and that last Orbital Sciences launch, they saw it all the way up to Newfoundland. It went right up the east coast, and it was a good time right after, it was before sunset here. It was past the sunset, the day-night terminator for Newfoundland, so they saw it come up over, and they saw the stage separation up over Newfoundland too. But if they're launching, say, a classified satellite and it's going for low inclination, and it goes right straight out to sea, sometimes those you don't see as much. They're not as visible.
Well, we're going to be a little shorter this week, but that's just what happens as we get close to the holidays. The team is trying to enjoy the holidays, and I think I might do the same. So why don't we start to wrap things up? But first, I would like to make a big thank you to everybody who has watched the show over this last year. It's been an absolute honor and a pleasure to be your host for all this spacey goodness, and a big thanks to all of the panelists who have joined us over the course of the year. The dozens and dozens of people, the regulars, and also all of the special guests. It's been great to have them all here with us. Big thanks to the WSH crew, the Weekly Space Hangout crew. These are, of course, is the dedicated community, which is about to go through, I guess, some kind of withdrawal for the next couple of weeks. But I know they're going to keep themselves entertained by talking space news on their Google Plus community page. So just do a search for WSH Crew on Google Plus, and you will join them and talk to them and recommend some other guests that we can talk to in the new year. A big thanks to Nancy Graziano for
Alex Parker.
What's that? Alex Parker?
Yeah.
Sure. Done. We're BFFs. No problem. I'm sure Alex would join us. We just have to ask him. We did a bunch of Pluto, the New Horizons hangouts together. So
yeah, you'll talk your ear off about image processing.
I can't wait to have that conversation. So over the next 2 weeks, David, can we give people like one thing to keep their eyes to the sky for?
Right after New Year's, we're going to have the quadranted meteors right around. Those have a very brief peak, January 3rd, and the Earth reaches aphelion actually around that time too. Oh, and another cool thing, if you're not watching Comet US-10 Catalina, it's about 5th magnitude. It's going to be passing very close to the bright star Arcturus right on New Year's Day. So if you have binoculars, that makes a good target. If you can find the constellation Bootes and you can find Arcturus, then you can find the comet right there. I actually haven't got to see it yet, so.
But in the morning, right?
Yeah, it's still in the morning sky, but it's getting better for. It's going to be a good binocular comet over the next few weeks for Northern Hemisphere observers.
All right, and David, where do people find out more about you?
I am this year. I've been active on AstroGuys, Universe Today. I picked up a gig at Sky and Tel. I picked up a semi gig at Sen for a while, and I'm putting out my weekly sci-fi chapters on my Amazon books. So if you want to read the other space opera that came out today, you can read a chapter out of my Solar Winds universe on AstroGuys.
Do your books make good holiday gifts?
They do, actually. They do.
Yeah.
There's I think I've got almost a dozen up there now. So on my that links right through. If you go to my Amazon AstroGuys, you can go to my Amazon page and buy.
Perfect. Oh, we lost Sandy. So, you know, she's Sandy everywhere, Sondy on Twitter, on everywhere. Her domain name. Kimberly, where do people find out more?
You can find out more by going to my Twitter handle, at AstroKimCartier, my website, which is KimberlyCartier.org, which has a mostly up-to-date account of my public speaking appearances, my radio appearances, and the work that I do for my real job, my research and things like that. And if you are in the central Pennsylvania area over the next few months and want to invite me to speak at your astronomy club, please do invite me, because I always love talking and meeting new people.
Sandy, I already told people how to find out more, but why don't you do the official version?
I'm Sandy on Twitter, and I'm apparently taking over Astro Tweeps for the first week in January. I should probably go ask the powers that be, or tell them that I'm doing that.
So I've got one last thing for everyone to go and check out. I did a collaboration with Kyrgyzstan, the Universe in a Nutshell people. They do these really cool animations. They're of sort of really cool concepts. They've done diseases, they do a bunch of space ones, and the Fermi paradox. And so we did one on black holes. I wrote it, they animated it, and it is freaking awesome. So go and check that out. It's called Black Holes Explained from Birth to Death. And it's super fun and just great to have all of the words animated, which is just amazing. So go and check that out if you haven't already seen it. I'm super proud of it. Well, hey, that's it. Time to wrap things up. So thanks, everyone, for joining us this week.
Thanks for hosting.
And we'll see you all
Next year.
next year.
Next year in
Happy
Google
New
Hangout.
Year.